Math 3, Unit 1, Section 3. Today we're talking about reflections. Two things that you are going to need to remember is that negative f of x means you're reflecting about the x-axis. And when you have f of negative x, like that in parentheses, it means that you're reflecting about the y-axis. Okay, you're going to want two different colored pens or pencils as we're going through this. And so the first thing we're going to do is graph our equations. So my first equation here, what type of graph is this going to be? Oh, it says right here, it's linear, it's a line, okay? And we also know that because there are no squared terms, there's no absolute value marks, okay? There's no exponents, and so we know this is a line. So what would be my starting point for f of x? Okay, what is the x value? -1, and then -2. Good. Also with lines, I think everybody's okay if we just start using the slope instead of plugging in points. Does that sound okay? All right, and so my slope on f of x is what? Very good, sorry. 3/1. Any questions on those values? Okay, so we're going to go to our graph here. And we're going to start by making our point at -1, -2. And then from there, we're going to go up 3, right 1. And we could also go down 3, right 1, or I might just keep going up 1, 2, 3, right 1. We just want to have at least 3 points on our graph. I think I'm going to have to make this a little smaller. Okay, so I'm drawing my line, and I would still try to label this, so that is my f of x line. Okay, the next one that we have to graph is f of negative x. And so with f of negative x, that one is going to do what? Okay, good. So that one reflects about the y-axis. So where is my y-axis? Is it vertical or horizontal? Vertical. This is my y-axis. Okay, and so you might want to write that if you forget that sometimes. And so what it means is that every point here on the line reflects to the opposite side of the y-axis. And so the easiest way to do this is, do you see how this point right here is 1 point away from the y-axis? So that means my other, when I reflect it over, it's going to go 1 point on the other side of the axis. This point that's on the y-axis, if it reflects, where is it going to be? Same place, okay. And then this one is 1 point away, but on the other side, and so we go 1 away on the other side. And then we draw our line. Okay, any questions right there? So far, so good? All right. Now, we graphed both of the equations, which was the A portion, and then it says, describe the translation of the original function from your parent graph. Okay, well, first of all, I want to make this is actually f of negative x, just so we have it labeled on here. Okay, so all of our parent graphs go through the point, what? 0, 0. And it's 0, 1 it's an exponential function. And so if we were to take the parent graph of this, the parent graph is actually y equals 3x. And so this parent graph, this f of x, was just, if we started at 0, 0, all it would do is, how would it translate? This would translate down 1. In order to get this point, right, to 0, 0, you would have to go down 1. So this from the parent graph, because we've been talking about parent graphs even though it's not on my graph, it would translate down 1. How do I write that in this form? 0, negative 1. Okay, and then C says, describe the reflection from the original function, which is my f of x, to the modified function, which is my f of negative x. So what did these two lines do? Very good. So it reflects about the y-axis. Okay, any questions? Now we're going to move on to our quadratic function. What will be my starting point for g of x? Is there anything with the x squared? No. So it's going to be 0, and then it will be 3. Very good. Okay, so with my quadratic functions or parabolas, we go and plot that vertex first, which would be 0 and then up 1, 2, 3. Okay, anytime that you have a curved line, we can't use this value as the slope. Okay, anytime you have straight lines, you can use that value as the slope. Okay, and so in order to find our other point, we're going to have to do what? Plug in a value. So we already have the value when x is at 0. So what would be a value that we should use? 1. 1 works, okay? We could use 1, we could use negative 1, we could use 2 or negative 2, but we always want to be within a couple points of our vertex, okay? So let's go ahead and plug in 1 to our equation. So that means I'm going to write y equals negative 2, and we're plugging in 1 for our point, so I'm going to write 1 squared plus 3. And I might, just so that I don't forget what I'm doing, put like a point over here, and we know we're getting 1 for x, and we're trying to find what the y is. So we simplify. 1 squared is what? 1. And so we go negative 2 times 1 plus 3, and negative 2 times 1 is negative 2 plus 3, which equals 1. So y equals 1. So my point is 1, 1. Suchi, you want to grab this? Sorry. Okay, so go to your graph, and we're going to go right 1, up 1 to make our point. And we know that with parabolas, they are what? Starts with an S. Very good. Symmetrical. So if this is 1 point away from the y-axis here, that means on the other side it is 1 point away. And so could I plug in negative 1 and get the value of 1? I could. But since I know it's symmetrical, I don't have to take the time to do that work. And then we have our 3 points, and we can draw our parabola. And again, we know parabolas have curved figures. Okay, any questions right now on here? Okay, what does it mean when you have negative g of x, that negative in the front? Good. And so we know g of x with the negative in the front like that. Okay, that one is going to reflect, I'm just going to put reflect over x-axis. So do you remember what we did when it reflected over the y-axis? What did we do? Very good. We counted the spaces between the y-axis and where my point was. So guess what I'm going to do with this one?
The same thing.
The same thing. We are going to count the spaces to the x-axis though, since we're reflecting to the x. Remember, our horizontal line here is our x-axis. Okay, so I'm going to move this up. So how many points is this away from the 3? So we're going to go 3 to get to the x, and then we're going to just go down another 3. So there's my vertex. Okay, this point is how many away? 1. So we're going to go down 1, and on the other side, down 1, and we draw our new parabola. I also forgot to label these, so I'm just going to put a label here that this is negative g of x, and up here this one is g of x. Are we okay? All right, so if we took our original function g of x and we wanted to make it our parent graph where it goes to 0, 0, what would you do with that? Down 3. So in order to get to the parent graph, you would have to move it down 3, which means it would translate, and what would I write? Negative 3. Oh, no. 0, negative 3. Good. Yes. Okay, so it's basically going back to like lesson 1. So let me just get there for you. And so back in lesson 1, so remember in lesson 1, our parent graphs would all start at 0, 0. Except for exponential functions, those all started at 0, 1. And so it's just basically asking you, what would you do to this in order to get it to 0, 0? So this would have to move down 3. Okay, and then again, the original function to our negative g of x function, all it did was reflect about the x-axis. Okay, any questions? All right, next one, linear absolute value. With linear absolute values, are they straight lines or curved? Straight, right? We just kind of have like 2 straight lines that go into a V. What that means is we have a slope that we can use, okay? And so I'm gonna show you how to use the slope with linear absolute values. So starting off with our h of x function, what will be my starting point? And in this case, my starting point is called the vertex. What is my vertex? Very good, 4, 0. Okay, my slope on this one is 2 over 3. Okay, so we're going to make our first point on the graph, and we're going to go right 4, up 0. That's my vertex. From there, we're going to use our slope. So our slope is up 2, right 1, 2, 3. And then, because it's linear absolute value, it means that it's also going to be up 2 and left 1, 2, 3. Remember that it's symmetrical as well. If this doesn't make sense to you, you can always choose a point, okay? Are there questions about any of these numbers and the slope? So when can we use slope? Straight lines. When do we have to plug in points? When it's not a straight line, so curves. Okay, curves, parabolas. All right, so let's talk about this. Let's talk about part B before I graph my other one. What would you have to do in order to get this to 0, 0, to where the parent graph would be? Good. You'd have to shift it left 4. And so translating that, we would write that as what? -4, 0. So all it's saying is, in order to get this to 0, 0, we'd have to move it left 4. Okay? So now back to our instructions. It has h of -x, which means we are going to reflect it which way? Very good. Reflect over y-axis. Okay, so what does that tell you here? This is our y-axis, and so what will I do? Count how many points, where they're away, right, from the y. So it doesn't really matter where we start, but this is how many points away from the y-axis? 1. So that means over here I'm going to go 1 point away on the y-axis. This is how many points from the y-axis? 4. And so we count 1, 2, 3, 4 on the other side of the y-axis. And then this one was how many away? 7, I think. 1, 2. And then we draw our lines. And we should also label them. So this one is h of -x, and this one was h of x. Okay, and then the last thing we're just going to write is what happened here, and that is that we reflected or reflect about the y-axis. Okay, please ask me a question. So, thumbs up, thumbs down, how do we feel about this? Okay, some of you are not voting, so I'm assuming that we're okay. If you are not getting it, if you give me a thumbs down, I'll just come and check in with you a little later. Okay, last one, we have an exponential function. Exponential functions are the only ones where I feel like we actually need to start with our parent graph information. So, on our exponential function, what is my parent graph? I'm just going to write here, parent graph. So if you take out all of the translating information that they've given us in that equation, what would be my parent graph? Y equals 2 to the x power. So all you're doing is taking the base and putting x in the exponent. That would be your parent graph. That would be your starting point. And so if we plug in values for my parent graph, I'm going to make a little t-chart here to the side. The two values we always choose are 0 for x and 1 for x. When I plug in 0 for x, which value do I get for y? 1. Good. When I plug in 1 for x, what value do I get? So do you remember what we do on our graph? We're going to put x's at these points because they're not actually points on our graph, but there are starting points before we translate. So I'm going to use a different color, like a pencil, or mine's a black pen. And I'm going to make an x at 0, 1, and I'm going to make an x at right 1 up 2. Okay, so now for my j of x equation. How does that translate? What is my translation? Good. Right 3 and up 1. So I'm going to write this in words as well. Right 3, up 1. Okay? So we got that information from the g of x equation, and so I'm going to go to each of my x's down here, and I'm going to go right 1, 2, 3, up 1. Right 1, 2, 3, up 1. Also, what's going to happen with my asymptote? Up 1. Very good. And so we're going to go ahead and graph this. And that is my j of x equation. Now, if we go to our part B, what would it take to start from here and go back to my parent graph? What would be that translation from here to my parent graph? Good. Left 3, down 1. So that would be starting at j of x, starting at j of x and getting back to my original function. Okay, questions? So now for negative j of x, what am I going to do? Reflect over x-axis, correct? When we have the negative, oh, you can't see what I'm looking at. When we have our negative j of x, that means to reflect over the x-axis. So we're going to take all the information that we have in here, and all we're going to do is reflect it over our x-axis. This is our x-axis. So where is my asymptote going to be? Good, -1. This point is how many away from the x-axis? 2, so I go down 2. And this one is 1, 2, 3 away, so I go 1, 2, 3 away. And then my curve, again, remember it gets real close to the asymptote. So it looks something like that. And we're going to label that as negative g of x. Thank you, j of x. And all we're going to do is write that it reflects about the x-axis. Okay, questions? Okay, so we're going to go ahead and turn this over, and we have our original function, f of x, and they've graphed it for us here. Okay? They want us to state the domains and the ranges for each of these and also graph them. Okay? So we're going to write the domain and range both ways. Okay? And you'll find that on your quiz today when you take it, it'll tell you specifically to write something in interval notation or inequality. So remember, inequalities where you use your inequality signs, and intervals where you use your brackets and parentheses. Okay? So looking at this graph right here, finding the domain. Domain is our x values. Okay? Now, I'm going to show you something, and I don't know if this is going to make it better or worse, but if you are struggling with domain and range, I'm going to try to help you out here. Okay, so here, this point, what is that exact point? -5, -3. Do you guys agree with that? Okay, this is my x value, this is my y value. And so if I'm dealing with domain, I am only writing which values? The x. And so that means, and does it equal, is there an open circle here? No, so that means we're going to use a bracket for this one, and it's at -5. And then you'll notice that this keeps going and going and going and going, and this is where the graph ends. Okay, what is this point right here? 3, -3. Is everybody good with that? Okay, and so, but again, we're just dealing with the domain. And so I am only going to write down which value? The x. And so that means I'm going to write down 3. And will I use a bracket or a parenthesis? Bracket. Did that help some of you? Yeah? Yes. Hold on, I couldn't hear you over the air. You still can understand what? The points in between? Because it's continuous. So everything on here has an x value, okay? So they're basically saying all the x values are between these 2 points. So between -5 and 3, there's, you know, a -5 and 5, there's a 4, so this is saying any values between -5 and 3 have an x intersection. Yeah, so if there's an open circle or a break in the graph, then it's going to change. And we're going to move, like, as we go on into this other, we get to this piecewise function set. And actually, then tomorrow, doing restrictions, you'll see where there's going to be no breaks in the graph. But right now, see how this line keeps drawing and drawing? There's going to keep drawing from -5 all the way up to 2. Does that kind of make sense? Okay. I can give you some other examples later, okay? And we can talk through that. Okay, any other questions on this? All right, so how do I write that in inequality notation? Very good. -5 is less than or equal to x is less than or equal to 3. And I use the equal to signs because of the brackets. Did any of you try that on your own and get it correct? Good. Okay, range. So range is the same thing. And we'll go ahead and write down the points as we go through here. Okay, but we're starting at the bottom and we're moving up on the y-axis. So this is the first point. This is my smallest point on the y. Do you guys see that? And so what is this ordered pair? 2, -4. And when I am dealing with the range, I'm only using which value? The y. And so what am I going to write first over here? Good. And I'm going to use a bracket. And why am I using a bracket? Good. Solid line. There's no open circle. Okay. As we go up, we're just kind of checking to see, okay, where does this graph finally end on the y-axis? And it looks like this is my last point right here on the y-axis. What is this ordered pair? Okay, this is at -2, 0. Okay, and again, we are only using which values? The y. And so where does it end? 0. And I'll use a, okay, I'm going to give you about 10 seconds to write that in inequality notation. Okay, how do I write it? Good. Good. So it just has the y in the middle, and that is inequality. And if you want to write this here, this is interval, and this is inequality. Just in case you forget, you can come back and look at that. All right, so on this next one, if we move right here, what it is asking us to do, and I'm going to have to make this, it is asking us to translate our original function. How is this one going to translate? It is going to translate 3, 4. And we can write this out in words as well. That is right 3, up 4. Sure. Okay, now what I want you to do, give me 1 second. This point is the only point on the graph I didn't have an ordered pair for that I've already written. What is this ordered pair right there? 0, -2. 0 on the x, -2 on the y. In order to translate these best, put an x on this graph, and actually you're going to end up putting an x on each one of these 4 graphs when we translate it, but an x for our original function, and then we're going to translate it. So it's like we have the original function on here with our x's, and then we're going to move them. Do you guys understand what I'm asking you or no? No? Okay. So do you see how our original f of x function has a point at -5, -3? So what we're going to do is we're going to go -5, -3, and I'm going to make an x there because we need to end up translating it right 3 up 4. but we're just going to start by putting our original function on here with our x's. Okay, and so my next point is at negative 2, 0, so I'm going to put an x at negative 2, 0. I'm going to put an x at 0, negative 2, an x at 2, negative 4, and an x at 3, negative 3. And so now we're just going to translate. So each of these x's now, I'm going to move them where? Right 3, up 4. So starting at the far left, I'm going to go right 1, 2, 3, up 1, 2, 3, 4. And make my point, because that's going to be my actual graph. Okay, then I'm going to go to the second one. And I'm going to go right 1, 2, 3, up 1, 2, 3, 4. Okay, going to the next point, right 1, 2, 3, up 1, 2, 3, 4. At the bottom here, right 1, 2, 3, up 1, 2, 3, 4. And then my last point, right 1, 2, 3, up 1, 2, 3, 4. And then we have to connect our points so that it looks like this function. Okay? And so my first 2 points, those make a straight line. Okay? The next 2 points make a little bit of a curve. Then it goes and makes a straight line, and then it goes up and also makes a straight line. Very good. So now we just have to write the domain on here. So again with our domains, I think we should write our ordered pairs if you're unsure. Okay, and so this point as an ordered pair is what? Good, negative 2, 1. And so when writing my domain, how am I going to write that? We're only going to use the x, and so my starting x value is negative 2. Very good. Notice how this graph goes continuously around here, which means there's x values. There's a whole bunch of x values going. These are all x values, and then the x values stop at this point. Okay, what is this ordered pair right here? 6 what? Good. X and y. And so dealing with my x's, there are values between negative 2 all the way up to 6. So if you chose any value between negative 2 and 6, you would find it on the graph. You could find an x value on the graph there. Okay, writing that in inequality would be negative 2 is less than or equal to x is less than or equal to 6. Okay, now for my range. My smallest range value, we go here, and what is that smallest range value? What is this ordered pair?
0.
What is it? 5, 0. Good. X, Y. No. Okay, so what is the smallest range value? What's the smallest Y value? 0. Okay, and so we write a 0 there. And as we go up, the highest range value, the highest Y value is at that point, and what is that ordered pair? Good. 1, 4. And so that means I would write what for my range? 4 is correct. And again, a bracket. And writing that in inequality would be 0 is less than or equal to y is less than or equal to 4. Okay, do we have any questions? Okay, so we're going to move to the right, and this one has negative f of x. What does negative f of x mean? Good, so I'm going to write that. Reflects over x axis. Okay, so just like I did on this other one, you need to put x's on your original function values. Okay, and so if you look back at your original function, we're going to put x's for each of these points, and then I'm going to reflect them over the x-axis. Okay, and so my first point that I'm going to mark on here is at negative 5, negative 3. And again, that came from my original function. We're going to make an x at negative 2, 0. We're going to make an x at 0, negative 2. An x at 2, negative 4. and an x at 3, negative 3. Is anybody confused by those x's? How do we make something reflect over the x-axis? There's the x-axis. What do we do? Good. Count the spaces to the x-axis, and then you go on the opposite side the same amount of spaces. So this first x, it's 3 away from the x-axis, so I go 3 above the x-axis, and I actually make my point because that's my part of the graph. By using x's and points, you can tell the difference between what is supposed to be there and what was originally there. And make sure you're not on your cell phones right now. Okay, this negative 2 point, okay, does it go anywhere? No, because it's on the x-axis, so that one actually stays there. Okay, this point, how many points is it away? 2, so we go up 2, make our point. This one is how many away? 4, so we go up 4, make our point. This one is how many away? So we go up 3, make our point. Again, we want our points to look similar, our graph to look similar. So from my first 2 points, it's a what? Straight line. Okay, my next 2 points, it's a curve. But because it's reflecting, it's not going to curve down. It's going to end up curving up. So the curve is going to look like that. Okay, and then my next 2 are a straight line, and the last 2 are a straight line. Okay, we're running out of time, and so I'm going to help you with this again. But starting with my domain, what is this ordered pair right here? Good, negative 5, 3. And so for my domain, we start at negative 5. Good. Okay, and then we go all the way through, and this ends here at this point, which is at 3, 3. And so my domain ends at 3. And writing that in inequality form would be negative 5 is less than or equal to x is less than or equal to 3. For my range, my smallest range value is right down here, and that point right there is at negative 2, 0. And then, so on my y, it starts at 0. Good. Going up here, this point right here is at, good, 2, 4. So for my range, it ends at 4. And in inequality form, that would be 0 is less than or equal to y is less than or equal to 4. Okay, the last one we're going to do is just the one down here, and this one is going to reflect over the what? Good, reflect over y-axis. Okay, so if we're reflecting over the y-axis, again, we always have to start with putting our original points on here with our x's. And so my first point is going to be at what? Negative 5, negative 3. Sorry, my first x is at negative 5, negative 3. The next x is at negative 2, 0. Then we have one at 0, negative 2. We have one at 2, negative 4. And we have one at 3, negative 3. And again, I got this from my original function. Any questions on that? Okay, so what am I going to do in order to reflect this over the y-axis? We're going to count how many points each of these x's is away from the y, correct? Okay, so this point right here is how many away from the y? 5. So we go across 1, 2, 3, 4, 5. I make that point. Okay, I'm just going to go from left to right as I'm doing this. So this one is how many away from the y? 2. So I go 1, 2, make that point. This one's on the y-axis, so it just stays there. Okay, this point is 2 in the other direction of the y. So 1, 2. So we go another 1, 2 to the left, and we get that point. And then this point right here, we're going to go 3 to the y-axis, so we go 1, 2, 3. Okay, and we know we should have 5 points, and we have 5 points there. I like starting where my original function was, and going back up here, we can't see everything, how do I have it? But you know how you have a straight line going from the first 2 points? So I'm going to start on the left side, and I have a straight line going for these 2 points. Okay, now think about the reflection. Okay, and so if I were to take this and flip it over onto this side, do you guys see what the curve should look like? And so we go over here, we connect these 2 points with this curve. And then we draw our lines. Okay, so writing the domain, what will be my domain value? So this ordered pair is at -3, -3. And so that means my domain will start at -3. Over here it ends at 5, -3. And so that means it's going till 5. That is -3 is less than or equal to x is less than or equal to 5. For your range going up, the smallest range value down here is at -2, -4. So we only deal with the y, so that is at -4. This point right here is the highest y value, and that point is at 2, 0, and we only take the y value, so that is at 0. -4 is less than or equal to y is less than or equal to 0. Any questions?